Hello and welcome to HGV Webinars with me, Rob Cockerill.
And me, Thomas D.
Now, back in April, I was here on HGV Webinars discussing hydrogen mobility. Part of this discussion surrounded the infrastructure and the chicken and egg dilemma we face in this constantly developing energy transition. And today we're back, this time with a different kind of infrastructure to tackle the power pillar.
We certainly are, and over the next hour or more, we're going to hear from our esteemed panel of industry experts to see what they have to say on the landscape of hydrogen power, hydrogen hubs, electrolyzers, and how it will power our future. And we'll get right into that after this short message from our sponsors today, Burkhardt Compression. Welcome back. Now to open the discussion, we're going to take a look at hydrogen electrolyzers with Tina Anderson, Applications Engineer at HiStar. HiStar is a spin-off company from Syntef, one of Europe's largest independent research organisations. It is in itself a self-proclaimed high-tech company that specialises in advanced PEM electrolyzers for large-scale green hydrogen production. More than that, it has huge ambitions to shake up the world of electrolyzers with its game-changing concept for water electrolysis that could go on to pave the way for a potentially pivotal role in the transition to a hydrogen-fueled future. Tina herself joined HiStar in 2021, working closely with customers and the product development team to make resilient and high-performing PEM electrolyzers, working to find cost-efficient setups for applications for large-scale industrial offtake, such as refineries, the ammonia industry, steel, other metals, glass, as well as the transportation sector. Tina, thank you for joining us today. It's great to have you on the webinar. Perhaps you could start by telling us about HiStar and these ambitious aims in electrolyzer technologies.
Thank you so much, Tom. Thank you for having me. Such a great time in the hydrogen industry. I think we can all agree on that. So much going on. We finally, I guess, see some solution to the chicken and egg problem, and there's so much going on. So first of all, from HiStar side, our main part in the industry is, of course, our patented solution that enables better efficiencies. We deliver PEM electrolyzers, and I will be sharing today a bit more about this technology. We are a relatively new company, so many of you might not have heard about us yet, but we are here very passionate about what we do, ready to create a greener future, I must say, for us all, and also, of course, to put electrolyzer a bit into this power and renewable setting, enable then higher penetration of the renewables into the grid. So it's a lot of things going on, and I was thinking first I could share a bit about the solution to explain a bit what makes us different from others. So here, I'm sure most of you have some background knowledge into hydrogen, but of course, the main thing you want to do when you produce hydrogen is to do it as cost efficiently as possible. Since this is in fact driving then how much hydrogen you can efficiently deploy around the world. So the main input in terms of cost would then be the capex of the system, with the costs you need to operate the system. So here, of course, you have so on the left side here, you see a relatively conventional cross section of electrolyzer stack. So this is consisting then of a relatively thick membrane. Of course, I say relative here because it's still quite thin. Okay, I get this feeling it might be something wrong with the sound. Is it okay, Rob and Tom?
It's a little bit intermittent, Tina. We'd be happy to try and continue with that if you are. But we can just about make it out, and it's good that we've got the support of those slides.
Yeah. Okay. So I try, and please let me know if it's getting worse. So the main thing in a PEM electrolyzer stack is that you do have relatively high ohmic losses in the system. And the ohmic losses are due to the thickness of the membrane. They're relatively proportional to the membrane thickness. And of course, most PEM electrolyzer manufacturers are therefore effectively trying to reduce this thickness in different ways. So from HiStar's way, we found a very innovative way to deal with this problem by then ventilating air on the anode side. To do so, we have moved the water feed from the anode and over to the cathode side. And this anode side is now being continuously ventilated with air, which then ensures that you at all times have an inherently safe operation and mitigate the crossover problem, which is a main problem, I guess, for all PEM electrolyzer manufacturers, and the reason you actually have to use in the conventional setting relatively thick membranes. So that was sort of the idea that started HiStar in the first place, and two of our co-founders have been working within this field for more than 15 years, doing electrochemistry, predominantly then within the field of fuel cells and electrolyzers. So I think you're all pretty much interested in seeing exactly then how much advantage could you see by using our efficient solution. So I think we can move to the next slide. So at conventional current densities, this is relatively standard to have around 1.5 to 2 amps per square centimeters. So in these polarization curves you have in front of you here, you see that at these conventional production rates per stack, we are operating at around a 15% decrease in energy consumption. On the left axis, on the y-axis here, of course, the voltage is proportional then to the energy you need to pay for and going into the system. So you will at all times want to have the voltage as low as possible. At the same time, our thinner membrane and our setting there enable us to go up to much higher current densities. So you can, with our system, go as far up as 3.5 or even up to 4 amps per square centimeter, enable then a much higher production rate per stack. So this has a major advantage than the CapEx side of the system. So we are in fact targeting both to deliver low-cost solutions, especially then focused to deliver really good solutions for the renewable sector, or we will deliver mainly for that 24/7 operation where the margin of operation is so critical, the very, very best energy efficiency on the market. So moving a bit further along to the next slide, I can tell you a bit about our current commercialization steps. So here you do see our timeline, how we're taking each year new steps towards full commercial scale. So up to now, we have been mainly focused on making the very, very best stack system in the world, optimizing all parts of the stacks, using the best components available in the market, and enabling a system that's possible to mass produce in an automated production line. We are also currently undertaking our first large-scale project to be installed in the field next year. That is a 1 megawatt unit that will be placed at Equinor, a Norwegian petroleum company's site in Norway. So we're very excited about this project and looking very much forward to commission that next year. From there, we are scaling up, taking things step by step, but we of course want to take part of all the interesting things that's happening at the moment in the market, and we do see ourselves as one of the larger players within this field within some years from now, and we do believe that our inherent benefits of our patented solution will help not only us as a company, but also the hydrogen industry then to take further step towards reaching cost parity with petroleum and fossil fuels. So that I think is the main motivation for everything we do at HiStar to enable the penetration of hydrogen for all sectors. Like you said, Tom, ranging from industrial application to transportation and energy storing and everything in between. So we are here for the long run, and I'm so happy to see everything that's happening in the market.
Fantastic. Thanks, Tina. A great look at the company and the solutions there that you offer. And I would say even with any of those sound issues, it's really clear there are some incredibly exciting developments in electrolyzers coming out of HiStar. Presumably you're perfectly positioned to step up to the EU's recent commitment just last month to pushing forward electrolyzer capacities.
Yes, we are looking very much into how we can effectively produce stacks. So in our current facility, we actually at the moment undertaking the plans of producing up to 1 gigawatt of stacks in our current facility, and this in an automated way, so that we can ensure, I think, further cost reduction through that, which is of course important to move along. But yes, given the current situation and the policies coming from European level, we are of course following that very closely. And I must say that as a society, it's important to move fast forward, both for the climate and everything there, but also of course to ensure that we have a good, stable energy security in Europe.
Absolutely. Well, thanks once again, Tina, and I'm sure that we'll have plenty more questions for you later on during our Q&A segment. So for those watching at home, if you do have any questions for Tina or indeed any of our panel today, do be sure to get them in and we'll do our best to get them answered.
Absolutely. Now we've set the scene with electrolyzers, but let's move along the value chain and hear from a leader and indeed another pioneer in the field of hydrogen production and storage. Cody Bateman is a true innovator in the field of advanced analytical techniques. He holds degrees in computer science and electric engineering and an MBA from Duke. Cody helped to define the concept of data warehousing and continues to be globally recognized as one of the founders of customer relationship management and data mining. He's currently CEO at GenH2, a position he has held for nearly 2 years. GenH2 itself is a provider of liquid hydrogen infrastructure solutions, advancing the renewable energy economy by accelerating the hydrogen infrastructure build-out. And not just accelerating the build-out, but positively disrupting it. Cody, it's a delight to have you and for you to be able to share your expertise with us. Tell us more about the energy landscape, how you expect it to change over the coming years, and how GenH2 is going to be sending shockwaves through the industry with its approach to infrastructure.
Yeah, thank you for having me here today. Want to make sure we have the mics working. Does it sound okay?
Absolutely, Cody, go for it.
Excellent, excellent. Well, this is a very exciting topic today, and it's actually very timely. So, for the last 2 years, all of us in the hydrogen infrastructure world have been sitting idly by waiting for this day to come. And so, only recently have you started to see the transition from the really, key topics of really cool applications, new cars and new concepts, and the focus has been on fuel cell technology. Obviously, what you're starting to see around the globe is the infrastructure now needed to be put together for all this to actually work and pull together. So today, instead of showing slides, I'd like to talk a little bit about the infrastructure is what the topic is today. So Gen H2 is a premier provider of liquid hydrogen infrastructure solutions. So liquid is really the key. So those of you that have seen me speak before, we've been focusing on liquid technology, or at least my team has, for almost 3 decades. Our mission is to advance the hydrogen economy by accelerating the infrastructure build out to support the energy needs, not only for the land, but the air, sea, and of course, space. Which brings back to really who we are at Gen H2. So those of us that have come out and seen our new global headquarters in Florida knows that we're tightly coupled with NASA. And so we're most of the team here came from working with the liquid hydrogen programs at NASA at Kennedy Space Center. And we've grown that technology. And as we did this work for the space world, we were finding out there was all these small solutions, these small concepts that are needed to advance this hydrogen economy, specifically on the infrastructure side. As I mentioned, we're based in Titusville, Florida, but we also have research centers in New Mexico. And this is a very important point to talk about, because what we have learned, especially dealing with liquid, is that elevation and humidity matters. And so as we build out infrastructure solutions, whether in the deserts of New Mexico to very cold temperatures in Northern Europe, we have to design infrastructure that works across all climates and all different variations of, like I said, altitude and humidity are the other two big ones. And so what we've done is we actually have the work we're doing here in Florida, extremely high humidity, almost zero elevation. Our research facility in New Mexico, 7,000 feet elevation, only 32% humidity. And what happens is that you start seeing changes of everything and how things work, including everything from the valves to the tubes and just the transfer of hydrogen. And it's very critical that we understand how to create a solution, infrastructure solution that are consistent across the board. And that's really what we've been focused on, especially for the last 3 years. And so our discussion today is focused on infrastructure, and that really is the focus for Gen H2 as well. So how do you grow and reach out to areas throughout not only the United States, but Europe? So right now, a lot of the infrastructure is focused on these hydrogen hubs in the US. We also see a number of these hydrogen hubs in Europe. But if you were to look at a geographical layout of where the hydrogen is, you'll start seeing large areas of every country that's going into the hydrogen economy with huge voids in it. And those voids is really what Gen H2 is focused on. And that's what we believe is really necessary for the hydrogen economy to really take off. So it's one thing to have these huge hubs in huge cities or next to major ports, which we work on as well. But the real key is, how do you get it out into the rest of the nations and out to the fields so the common person can use that? And so the key there is really designs up the 4 pillars that we work on at Gen H2. And so this does require a modular approach, and it also requires manufacturing at scale. So let me explain both of those real quick. The modular approach is much what you just saw what Tina had on the solution that they have at HiStar. If you'll notice, that was the containerized solution. You'll start seeing a lot of people in the infrastructure doing the containerized solution. This is actually critical so we can get the technology out quickly. And the only way to get it out quickly is for mass production, which is the second thing that we think is very important at Gen H2. And while we just got through developing a brand new manufacturing center, because building infrastructure one at a time or in small scale will not roll it out by the 2030 and the 2050 goals that we believe are absolutely required. So just like Gen H2, just like HiStar, uh, all the other major companies we're working with, we're looking at these containerized solutions, get them out there. In the United States, it's also all about permitting. It's actually easier to permit and get these things installed and operational quicker using a modular approach. So let me take a few seconds and step back and talk about the 4 pillars that we work on at Gen H2. The first one is the production. So we do have advanced research in pyrolysis. A number of companies are chasing that point, but we're molecule agnostic. And we think that's important to understand, that we support everybody that goes around and creates the hydrogen. But we're going to be focusing on the hard part, which is the liquefaction and the storage. And then lastly, the transfer piece. So each one of these pieces are also very important. As I mentioned, liquid, I do believe, is the future. It's a lot safer, and it's actually more energy dense, and it's actually easier to transport. And so the liquefaction piece we've been focused on is not the large scale liquefaction that you'll see at companies like Linde. We're actually, once again, looking at the smaller scale work that can be done in the 1 to 5 ton per day liquefaction and storage solutions. And that leads us into the storage. So currently, we do have a design for what's called the gigasphere. We actually, our design engineers worked on the largest liquid hydrogen tank ever built. It was built by CBNI. It was built for the mission to the moon and hopefully to Mars soon. And it's 1.25 million gallons of liquid hydrogen. That is just a massive amount. But we have designs that can take that's currently going into place right now. It's about to go live. But we can take that design, we've been able to optimize it so that we can now go to mass scale. So if you can imagine this one giant sphere, which took years to design and years to develop, we can actually get to the point that we can say and safely say that we can actually start mass producing these gigantic spheres, which are needed for all the major hydrogen hubs, not only in the US, but around the globe. But the second piece then is to look at we have all the people like Chart does phenomenal jobs with mid-scale storage, but then the small scale, how do you store liquid hydrogen at 1 ton per day or 5 ton per day? And I've been seminars as recently as 5-6 months ago where people were saying that's impossible. I'm here to tell you today that not only is it possible, that is exactly what we've been able to optimize, and we'll be taking to the market very soon. So very exciting things going on in Gen H2. We're already starting to sign our first contracts. We're out there promoting the fact that we can build infrastructure at scale at the smaller areas, not necessarily in the major hubs. And then also we have new transfer technology that will allow us to go liquid to liquid, because we do believe that, like I said, long-term liquid is going to be the solution, not only for the class 4 to class 9 trucks, but also for aircraft, ships, and even drones. And so hopefully later this year, you'll be hearing about some of the world record-breaking technologies that we have for liquid hydrogen flying drones. So that's pretty much in summary, and I'd like to hand it back and looking forward to the questions.
Thanks, Cody. That's fantastic. You can hear all about those breakthroughs at H2View, of course. I'm sure we'll work together on that, Cody. Fantastic points there around the modular approach. Also very interesting about the different conditions. Humidity and temperature, and that transfer of hydrogen. I think we may come back to that in the Q&A session, but just to pick up on your last point, looking at Gen H2, what industries are you across, and how can you help to change the way we think about power?
Yeah, it's amazing that when we first came up with the Gen H2 and our liquid concept, we really did focus on ground transportation. Once again, semi-trucks. We thought that was, the lorries is probably the future of liquid hydrogen, at least in the short term. So that was an obvious one to go after. But it was interesting as we started coming up with our technologies, the ports started coming to us and people doing very unique applications of hydrogen. So probably like most people know on this call, that a significant amount of hydrogen is currently being used in the industrial areas, right? So Tina actually brought up the concept of metallurgy is out there, obviously making ammonia heavily for fertilizers, where we're finding out there's actually competition for the hydrogen we want for the transportation industry back in the other industry sectors. And so you're going to see that continuing to grow, which could be a challenge we'll talk about a little bit later, but that could be a challenge to really hitting some of the clean technology goals that we have in place for 2030. But I'm really excited about the fact that not only the drones, but we have a couple of aircraft companies we're currently working with. I love the concept of liquid hydrogen for long-term flight. And then, of course, shipping. I'm amazed at the number of not only ferries, but other ships and sea craft that are actually using hydrogen. So it's across the board. Anywhere energy needs to be stored, hydrogen is going to be the solution.
Fantastic sentiments there, Cody. Thank you.
Yeah, we no doubt share that excitement. But finally, Cody, I recently spoke to Darryl Wilson of the Hydrogen Council about what's holding back the hydrogen economy, some international policy issues, as well as the challenges that the industry faces. Should we just take a quick look at that conversation, and then we'll get back to you and get your take on the obstacles we face and how we can solve them. Hi, I'm Tom D. We're here live in Rotterdam for the World Hydrogen Summit, and I'm joined by Darryl. Darryl, if you just want to introduce yourself.
Hi, Darryl Wilson with the Hydrogen Council. Great to be with you.
Thanks for joining me, Darryl Wilson. We've just heard your opening keynote speech in there. Perhaps you want to give us a quick rundown of what you went through.
Sure. This conference here, lots of excitement and so many people and great program. So a lot of momentum in the sector and a huge portfolio of projects, but one of the points I made is 95% of it sitting on the pre-side of final investment decision, and so we need to get those projects over the line and delivering in the interest of climate change. And so I talked a little bit about some of the things that are holding us back. We need some certainty on the demand side. We need to see the funding move into actuality. We need to make sure that the standards around the trade of hydrogen start to become uniform and shared so that there is indeed trade. If you look at the latest ambition from Europe to add so many more metric tons of hydrogen demand, much of it coming from the trade side, we need the standards to be aligned and working together so that trade can be effective. So lots of momentum and opportunity, but also still some challenges to bring things across the line.
And the industry has all these opportunities that you've just said. I know it's very simplistic to say what's the solution, but what will help us get there?
Well, it's a partnership between industry and government, so it's not one side making the other side wait. We need to roll up our sleeves and crack on with this, as they say in the UK. And so I think it's incumbent on all of us to do our part and to make these things come together and achieve the actuality of impact.
And presumably that's what you want to see going forward into the future.
That's right, yeah. On the Hydrogen Council, we've got many member companies bringing a lot of capability and scale up to the table. So I think there's a whole first flight of projects that have to move into reality, and then we can get on to the next because the ambitions and the targets have been raised again, and so we need more capacity and capability to come into the market to deliver on that additional demand. But my main point today is let's get what we've planned over the line and into actuality.
And that's your key point today, and how have you found this event as a whole?
Very exciting. It's great to be back meeting in person. It's so much better, sitting around tables at meals and having relaxed conversation, the kind of thing that doesn't happen on a two-dimensional screen. So it's been a delightful thing to be here.
It really has. Thanks for joining me, Darryl. But I'll leave the last words with you. If you had a key message to anyone watching or anyone here at the conference or exhibition, what would it be?
Let's work hard to do the hard work of implementation. Making announcements and plans and targets, all very necessary, but the hardest work of all is implementation, and that takes teamwork on the public sector and the private sector working together to bring these things across the line.
Absolutely, Darryl. Thanks for your time.
All right, thank you.
Darryl Wilson of the Hydrogen Council there. Cody, are those points that he makes ones that you agree with, and what other challenges do you believe that the industry face?
Yeah, I mean, Daryl's always dead on, man. He's a great speaker and a great leader, and it's always great to hear him speak at your conferences. But I mean, the two primary points he brought up that I wrote down, one of was the certainty of on the demand side, right? And that's definitely the case. And so it's interesting that you're starting to see more and more applications, especially if you go to these trade shows. So you're starting to see not only the infrastructure, but you're starting to see like Cummins. I went and looked at their latest hydrogen engine the other day. It's adapted from diesel. I mean, people are really taking this serious. They're starting to build up the actual production. So I think the demand side is coming. What's exciting to us is we're actually seeing the demand grow. And so just this week, Department of Defense has come to us and has asked us about doing some very unique projects for the military, which is my background. Some of you know is heavily based on the DoD work, and now to see that the military is looking at hydrogen not just because it's clean tech. There's a lot of advantages that are starting to come out, and as we start to see these advantages, especially creating power at no noise, just amazing. Being able to power a large platoon or something with no noise. It's pretty incredible what we're starting to see. And then how do you store that energy long term? So the demand side, I think, is key. The second one is, I completely agree with him, is standards and getting the standards to be the same across the globe. We can't just have US standards, European standards, and standards in Japan or Australia. So I agree, the standards, that's a huge key point. But we have a couple other topics I'd like to discuss real quick, challenges that I think are important to address at this point. One is the one I said earlier, was the continued growing use of hydrogen outside the transportation industry. As that grows, we may not have as much hydrogen as we anticipate to really fuel the transportation sector. So that's one big issue. But another challenge that I'm starting to see right now is setting realistic goals, and then once again, use cases, how it could be used, and then understanding how each one of these goals apply to the 2030 and 2050 objectives you see out there. And then cost, of course, is the key. But we have great companies out there like Tina's. They're working on the cost of hydrogen and bringing that down. We're working on the cost of storage and liquefaction and bringing that down. So those are the key points on the challenges I see at this point.
Well, thanks for your take on that, Cody, and we'll no doubt be back to you later for our Q&A segment. But before then, we'll speak to our final guest after this short break.
Welcome back. Now, our third and final guest today is Jako Rajek, founder and chief commercial officer of Netherlands-based consultancy and engineering firm eKinetics. Jako has an international automotive and industrial gases background, including over 20 years of hydrogen experience in automotive applications across the industrial gases and energy industries. He studied international automotive engineering in the Netherlands, Germany and UK, and his major was in alternative drivetrains, at a time when there were no commercial products in sight and the EV topic was far from popular.
With roles in electric drive and fuel cell R&D, infrastructure technology based on cryogenic liquid and high pressure gas, various pioneering roles in engineering, innovation, strategy, marketing and business development, Jako has a truly diverse portfolio of expertise. And Jako joins us now. Last time you were on H2View webinars, we spoke about hydrogen vehicles and how this industry will drive us forward. Could we now get your take on the infrastructure side of hydrogen mobility and how refueling will play an important role in this transition?
Yes, thank you, guys. Thank you for inviting me. And I think I would connect to my former speaker. It's indeed exciting times in hydrogen. And yeah, I think the statements from Daryl were quite spot on, to be honest. And to connect to that challenge that was mentioned before, I mean, we are introducing a new energy carrier. That is a big thing in itself. And we're trying to solve a complex problem. I mean, complex climate change, energy security. Those are big issues. And look at this round. We have, rocket scientists, energy scientists, and an industrial gases specialist to work on these kind of topics. I mean, this technology is far from mainstream still. And I think that is also one of the main challenges in this area. And this might also be one of the main reasons that a lot of these projects are before final investment decision, because you have to do the work, the hard work, in making good concepts, challenging them before you make that final investment decision. And I think still in the market, there's well, let's say the know-how is still scarce in this topic. And that's for me, that is one of the main challenges. And perhaps there's also something where we connect. That's also one of the things that brought us to become active outside of the industrial gases corporations into, engineering and consultancy, and work on that system integration in the sector. And specifically on these high pressure gas and cryogenic solutions to create systems for the energy system of the future. We work on 4 different of those pillars or sectors: the industry, energy, mobility, and the built environment. So for domestic heating, if you will. Of course, domestic heating is not a big, let's say, big topic for today. We're working on the solutions for tomorrow, for all of those houses that are hard to to make sustainable. So the old existing houses, the monuments, rather than new houses, which you can of course build quite well insulated, and maybe all electric is certainly a possibility. And in that chain, we work from the conceptual design over the permitting to the realization, commissioning, and finally the turnkey handover of projects. So really the EPCM work, engineering, procurement, and construction management is what we do in the as a service for both hydrogen and, not to forget, CO2. CO2 we often hear, in relation with greenhouse gas. But if we are to go to a hydrogen and electricity economy, and I think we are, and I hope we are, we need some of those carbon molecules to make stuff. And if we don't get it from fossil, we need to make it from, biomass or whatever. So the CO2 capture, reuse is certainly an important topic, and therefore we concentrate on not only hydrogen, but also on CO2. So if we look at, energy supply and energy security is of course an important topic for many places in the world, and now for Europe in particular. The main reason is of course climate change and turning away from fossil sources. But the other recent and maybe even more pressing is around the natural gas supplies and cutting down important sources. And you might think immediately about Russia, but not to forget Netherlands as a starting point for natural gas throughout Europe has also severely cut down in its production rates. And luckily, we still have some natural gas from Norway, Tina. But the sources are shrinking for several reasons, and that is a catalytic reaction basically towards hydrogen. So hydrogen was already on a big ramp up before the Ukrainian conflict, but that has only let's say strengthened that development. So in climate change, many people have focused on the electricity part for the past years. And that's also one of the challenges. We tend to focus on the wrong things, or maybe not on the main things. The much smaller part of energy supply, electricity, it's only 15%, more or less. Our gas transport grid is not visible. However, it is almost 15 times larger than the electricity grid by capacity. And to look at our houses, our domestic energy connection in the houses in Europe is 10 times larger in natural gas than it is with electricity. So the natural gas component, at least in Europe, has a much more significant role in the energy security and energy supply than electricity has. Apart from that, gas transport is about 10 times cheaper than electricity support. Billions of kilowatt hours storage, seasonal storage, are already existing in natural gas storage. So we need to replace those monthly storages of energy by another energy carrier, which the role of hydrogen comes in, and that can never be fulfilled by electricity. And I think that's more or less now starts to trickle down also to, let's say, policy making and the bigger picture, system of energy. And it's not about applications. It's not about solar panels, or it's not about, an electric car. It is about the system, the whole system. And it cannot be overlooked the role that fossil sources now have in our system, apart from the electricity as energy carrier. Only one salt cavern can carry 240 million kilowatt hours of energy in natural gas or in hydrogen, which is almost 5 million electric vehicles by capacity. So there you see, you would need 5 million passenger cars to carry the same amount of energy as one salt cavern has. And we, in the Netherlands, small country, we use 8 of those small salt caverns to, do the seasonal storage for the domestic housing and also for industry. So hydrogen gives you a means of storage and transport of energy that electricity cannot fulfill. And that's why now we have natural gas next to electricity. Now, if it were easy to, electrify everything, the role of natural gas would be played out. And I think Tina mentioned it, and Cody as well. I mean, the largest consumer of hydrogen today is certainly the fertilizer industry, which today converts natural gas and water to hydrogen and CO2. And that can also function with green hydrogen coming from electrolyzers, building wind parks or wind farms on the North Sea or in any places where you have a lot of wind, and then transferring that wind energy into hydrogen, which can directly be used by the fertilizer industry together with nitrogen from the air, and be over the Haber-Bosch system to make into fertilizer, which is perfectly possible, and I think also solves multiple problems. Yeah, and I think hydrogen definitely is a means of unleashing the potential of renewable energy production. In fact, you take the brake off any large ambition in regard to wind farms and solar farms or fetching hydropower with hydrogen as a storage and transport means. It is such an effective way of storing energy. And what we do there is we provide the pre-studies. We do the conceptual design basically before realizing these projects. We do it in Europe. We have a great project in Switzerland now going on. A 20 megawatt electrolyzer will be built. It will be run on hydropower in the Swiss Alps. That's always available. That's a little bit different starting point than a wind farm is. And that will be then the largest electrolyzer facility in Europe after the 10 megawatt, which is now present in Cologne, Germany. So we're still at, we are speaking about 200 megawatts and gigawatts, but we are really at the tens of megawatts in building installations in Europe. So we're quite proud of, being part of that. I think our work is being recognized. We're asked for projects in Namibia, for instance, to start up energy production there. And I mean, make no mistake, energy in Europe was never about self-sufficiency, something that also has to dawn on our policymakers still. Europe never was self-sufficient in energy and doesn't need to be. Let's just import energy also from other places in the world and use our own potential for building wind farms and solar farms where we can use the electricity directly if we can and store it in hydrogen as we need it. So we need system thinking rather than focusing on single solutions, and keep the main and the side issues apart. And that's also one of the challenges in this energy transition, and going from wood to coal to oil to natural gas, now to hydrogen, a completely new energy carrier. I mean, that's big. That has an effect on every living soul in a country. So it's not just a little problem. It's a complex issue, and we still need to work on growing experts all around the world, and people who will be working in this field to get all of these projects and all of these ambitions over the starting line even. Thank you.
And it's great to hear about some of those exciting projects you're involved in. On the subject of refueling, at the top of the show, Rob, you mentioned the mobility webinar from back in April. Let's just quickly remind ourselves of the chicken and egg dilemma that Rob referenced there.
Around the world, I would say the coordination is fairly good, always needing some adjustments. And really the opportunity is to go bigger and faster, to effectively launch rather than dip our toes in the water and do some trials that honestly at small scale are more difficult. Japan, the infrastructure and the vehicle introduction is fairly well coordinated. As I mentioned, in Germany, the infrastructure is a bit ahead. So that's good news for the availability of fuel, but it means that infrastructure struggles to be commercially viable. It doesn't sell enough hydrogen. And then in California, the infrastructure is a little behind, and there are long lines of customers at fueling stations, and there's not enough hydrogen supply to those stations, so sometimes they run out of hydrogen fuel. This is not a state of affairs that a well operating and mature industry should be in. So again, it's very difficult in launching small scale to have the robustness in a fueling network that is convenient for customers, or in a hydrogen supply resilient and robust and has enough buffer capacity. So I think as we talk about coordinating, we also should be talking about launching, about introducing hydrogen mobility into a market at sufficient scale to jump over those difficulties straight into a more robust. I often say we're trying to ask hydrogen to be competitive with gasoline and diesel at about 1/1000th the scale of gasoline and diesel. And so that's difficult, and we do better by launching a bit bigger.
That was Wayne Latey there of Shell. Now, Jako, I know we're veering slightly into the mobility side of things here, but obviously all of these infrastructure are connected. It's the system, if you like, to use your analogy. But what's your take on the scalability of hydrogen refueling infrastructure and the challenges we face in this scaling?
Well, I'm quite certain that the technology is very scalable. I mean, we also design and realize refueling stations for hydrogen. The challenge at the moment is that we've come from a time where we had these demonstration projects like was just mentioned. 3 buses running around the church and just showing that the bus can work. And then after that project was finished, the fueling station would be taken apart, taken away. So that was just demonstration. And now we are introducing first projects, your Hyundai, Hyzen, Toyota, Kenworth, a number of other, Stellantis, BMW, all introducing products. But as long as these projects are not, you cannot see them drive by on the road, the business case for the fueling station is quite bad. So the first ones who invest in these stations are the ones who lose money the longest. Everyone that's after that say, oh, I'll step in a few years when the market picks up. And that's the big challenge, because it's like this Mexican stand down, who will go first, and that's something to overcome. So it's more an economical problem, I'd say, than a technical problem. So I think technically there's absolutely no challenge for me for scaling up these stations. We have a clear path for that, but it's an economical challenge.
Absolutely. Sure. Thanks for your take on that, Jako. And I'm conscious that this is just one question before the Q&A, so I'm holding that up. But moving away from refueling and mobility, what do you believe to be the biggest application in the whole power pillar?
Yeah, well, fertilizer will by far remain the largest consumer of hydrogen, and then of course you have your industrial applications for all kinds of hydrogen, alcohols and all kind of chemistry you do with hydrogen, up to hydrogenation of vegetable oils to fats, fat hardening, etc. So I think that wouldn't start to change. And mobility, even if you do all mobility in hydrogen, which you don't need to. I mean, light duty vehicles can certainly drive with batteries. Hydrogen is far more better application than the heavy duty application, so the heavy users and the machines, etc., and the trucks. So that field will not change much, and mobility will not be the largest share of all the hydrogen consumption. So if you go down from top to bottom, industry will be by far be the main consumer. Then the energy system, runner up, probably 1, 2. Fighting for 1 and 2nd place, and then you have mobility, and then you have domestic heating.
Sure. Well, thanks once again, Jako. I'm glad you could clarify that for us. And you will be joining us for our Q&A session. I've already teased it once already, so if you do have a question for any of our panel, do get it in, and we'll put it to our panel after this break.
Welcome back. It's now that time of the show where we get your questions answered by our expert panel.
It is indeed, and we've got plenty to get through. So without further ado, let's dive into those questions. We'd like to come back to Tina first. We haven't heard from you for about half an hour, Tina, since the start of the webinar. So let's come to you for a moment. I made some notes actually from your talk. With Hystar's technology, you're heading towards a 200% increase in hydrogen production. We saw that, and at the same time, a 10 to 15% decrease in energy consumption, which are fantastic statements and figures to be able to put out there. We do have a couple of questions that have come in that ask about those technologies from another point of view. I'm just trying to find the first question, came in very early on. For Tina, what is the per dollar kg of hydrogen for the Hystar system? I guess, what are you working out there with dollar per kg?
Yeah, a good question. Just a slight comment to your comment regarding producing more 200% increase in production. It is not possible to at the same time with the same system both produce more at a lower energy consumption. You sort of have to choose each one of the modes, either the very high efficiency mode or the increased production mode. So just a small clarification there. If we were able to both things, then I think it would be a bit too large step. It would solve a lot of the problems that we're facing in terms of cost, of course, but currently focusing on bringing two separate solutions to the market, each having their specific tailor made for different applications, one towards more renewable use and intermittent use, the other one more towards the industrial sector. So coming back to your question regarding the cost, because obviously cost is a major driver how fast we can deploy hydrogen. So the main contributor to the overall cost or the levelized cost of hydrogen production is in fact the power price. So whatever you pay for each kilowatt hours of electricity, it has a major impact on the cost. So I see electrolyzer manufacturers saying that we can go to $1.05 per kilo of hydrogen. I do think we need to look at it more holistically, see what the levelized cost of electricity will be in different regions of the world. Some areas will have tremendously good solar conditions, some will be good wind conditions, and so on. And in these regions where you have available power at a very low cost, I do believe it's definitely possible to go down to $1.5 per kg, but that will not be the case for more normal average regions. Then it will be more in the $2.5 per kg or so. But of course, we're continuously working to improve. The solar industry is doing a lot in cost reductions as well, so this can of course improve further on.
Fantastic, thanks there, Tina. And you're absolutely right to clarify that. I mean, that would be a complete game changer. But to be quite frank, I mean, either of those capabilities are a massive breakthrough in themselves. So it's fantastic what you're doing. The other question we had on the technology itself, Gilam asks, does the thickness of the membrane have an impact on the durability of your electrolyzer?
Yeah, a very good question there coming in. Very educated listeners, I do believe. So the main thing was actually that this was a slight concern from our side as well when starting to develop this technology. So that was one of the first things that was tremendously important to get tested. So we did testing for more than 5,000 hours just to ensure that we had the durability. And you get sort of a fingerprint when you run this, and you see that it ran very stable. It does not have a higher degradation than other systems. So that was sort of like the very key thing for us as well to investigate. So we can safely say that it is working in a very durable and reliable way.
Fantastic. Thanks again, Tina.
Cody, I'm going to come to you. I've had a couple of questions in for you. This one's from Tim, and he asks, how many kilograms of hydrogen does it take to make a ton of liquid hydrogen?
Well, it's I don't even have that kilo in my that calculation in my head, unfortunately. But I can get back to you on that one. I usually have that off the top of my head. But yeah, it's about 1,000 kilos is the rough number. So 1,000 kilos is what we call 1 ton. And so people argue back a little bit back and forth, if it's an extra 100 or 200. The actual storage solution we have for our 1 ton solution is actually around 2,000 kilos. We think that extra capacity is actually necessary because exactly what Wayne brought up on that earlier video was, the offtake and everything is necessary at certain times, and we actually had the conversation about how some of the gas stations are running out of gas from time to time, and so it's basically 1,000 kilos is a ton.
Timothy's question there, we're in the right ballpark. Another one for you is, how does the size affect the efficiency and hydrogen losses of your system?
So that's a great question. That's exactly the reason why we formed Gen H2. And so our solutions are considered zero loss. And so we have a 0.05% true loss rate on some of our solutions here. But our goal is we actually take any venting comes off, we reliquefy it, we put it back into the system. That's a fairly novel concept that we've actually optimized several years ago. And so, but the sizing is what's really hard. And that's the reason why when the Department of Energy came to me 2 years ago and they said, can you form a company to actually focus and design something at smaller scale? So, you know, we've been doing large scale hydrogen, especially liquid hydrogen, 20, 30, 40 tons. Is actually, I hate to say it's easy, but we've been doing that for decades. The hard part was how do you scale it down? And as you get smaller below at 5 tons and below, really below 10 tons, the technology changes quite a bit. And only with some of the more recent advances we've been able to get has allowed us to achieve the 1 ton and 5 ton per day liquid storage solution. So it's very difficult. You won't get the efficiencies. You know, Tina just got through talking about the cost. I want to be very clear when we start talking about $1 or even $2.50 per kilo, that is at the end of production. There's additional costs associated with that. Liquefying the hydrogen, storing the hydrogen, so it's always there, that on-demand cost, you know, will increase that by, you know, $2 to $4 per kilo. But the key is you always have it. So if we're talking about the infrastructure required, especially for long haul trucking, a truck cannot show up to a gas station and not have fuel. It just that can't work. That's what we're seeing currently in California. So our goal is to make sure there's always hydrogen on demand at all times.
Sure, thanks, Cody.
Absolutely. Now, I thought we'd open this up for a moment for the whole panel and talk about perception. We've had a comment from Patrick Thomas, one of our viewers, who says, great logic from Jako. How do we educate the world leaders that are making the policy decisions, of course? And these affect the development of technologies. You know, Cody, I know we've discussed perception before on HTV webinars and virtual events, and also Jako, you know, you kind of described the proving ground and the very nature of this panel here, coming from different backgrounds, but not the mainstream necessarily. So perhaps I'd open it up. Do we still think there's a perception challenge to be met in hydrogen going forward? We'll come to you first, Cody.
Yeah, there's a lot of perception changes that are taking place, and I'm really excited about how the industry, especially these shows that we go to, these conventions, where people are starting to change the perception. And the key is how to change these perceptions in the eye of the end users. And that's really where I think the media is going to be able to help us out. I think, you know, magazines like yours are doing a great service to the hydrogen economy, but changing the concept of, you know, is hydrogen safe? Well, we know it is. Liquid hydrogen, even safer. If you look at the number of industrial accidents with hydrogen, even though it's been around for decades, is very minimal. So that's another one. And another one is just, can it be done? And Jako brought that up. I mean, you know, I don't think it's as much of a chicken and egg as people think it is. I think as we come up with more production, as Tina's company becomes more, you know, goes out there and starts making more efficient hydrogen, you're going to start needing people with different ways of off-taking this and then transporting the hydrogen around. So I think some of those perceptions are being addressed significantly just in the last 6 to 8 months.
Well, thanks very much, Cody. Thanks as always for that discussion on perception. Jako, your views on this? Do you think we still have work to do in project perception?
Oh yeah, definitely. I mean, let me use this metaphor. Yeah, if the lunchbox is energy transition, I mean, we often see these fights. You know, what is more healthy, a pear or an apple? Yeah, and while we should be focusing on the candy bar, yeah, to get that out of the lunchbox. And you see that, you know, if you focus too much on solutions in the entire puzzle, you get these kind of strange discussions. You know, is a battery vehicle better than a fuel cell vehicle or whatever? But if you have to look at the entire system, and then you learn to understand that many of the technologies are really complementary to each other, and I think that is a big chunk of work that lies ahead of us. If you look at, you know, getting these discussions more multifaceted and get the system thinking approach more in the heads of our policymakers and leaders.
Absolutely, thank you. And I unfortunately am always drawn to the candy bar in the lunchbox. I put my hands up. Tina, perhaps just some thoughts from you on perception as you see it as well.
Yes, I think more and more people are learning more about, and we see more and more solutions deployed. So people become much more aware that this is a real solution. It's available. It is safe. But of course, handling all sorts of energy, you need to put very close attention to making sure you have the correct protocols, regulations, and following those. And not only when building a system, like we put tremendous effort into making an inherently safe design, everything that goes with that. But of course, it also must be maintained in a good way, and make sure that you check sensors, recalibrate sensors, change filters, all this sort of like tasks you must do every now and then. Like for electrolyzers, not that often, but still, it is tremendously important that everyone that owns and operates systems as well take good care of it and make sure that it's continuing to being safe, because obviously the last thing we want is some damage to the hydrogen's reputation with accidents and so on.
Absolutely, thanks, Tina. That's a really good point as well that we must reinforce about safety. Thank you.
Absolutely, we've got more work to do on perception change, I think. Jako, I'm going to come to you for a question from Martin, who asks, how do you see the hydrogen demand for synthetic fuels developing, and for what applications?
Well, I think the hydrogen as an ingredient for synthetic fuels is very interesting, especially if you look at the airline industry. If you would use synthetic fuels based on hydrogen, maybe CO2 from biomass, and create a synthetic fuel as a drop-in fuel to conventional kerosene, you could yearly increase requirements on the kerosene globally, and in places where you cannot have synthetic fuel for whatever reason, you can still fly on the conventional kerosene. So that would be, I think, an excellent way of feeding in green hydrogen into the existing system of the airline industry, which is very difficult, to just switch over to, for instance, liquid hydrogen, which I fully understand. And Cody, I there are nights that I dream about these applications, but you have to have liquid hydrogen in any of those airports. So that's really a logistic issue, and you need to do those efforts. But in the meantime, work on the synthetic fuels, definitely.
Fantastic, thanks, Jako. I'm going to come back to Cody for a moment, if I can. We got a question from, or an observation rather, from Milan Sarkar in Asia, and he says, look, you discussed standards, and that's important, standardization. He asks, who do you think is currently working or leading almost in developing these standards and that harmonization, and what role is ISO or the UN or others currently playing?
Yeah, you're starting to see a lot of going on. I mean, what I like is the references going on back and forth. So you ask who the leader is. Honestly, some of the leadership I'm seeing from the standards coming out of Australia, Japan is amazing. But all of Europe, I would say, is probably 2 to 3 years ahead of the United States. I think we're just catching up. But as we pull this together, and we have like the Hydrogen Council that we had earlier on in the show coming together, we are bringing in the thought leadership together, and everybody's starting to nod their head on the best standards to approach. And so you're starting to see a lot of references between all this. I'm starting to see more and more in the U.S. government taking some of the standards from Europe and from Asia and putting it together. So is there one group, one agency really, leading the global standardization? I would say it's actually like 4 or 5 groups pulling that together. But I do think by the end of this year, you're going to see a lot of this stuff coming together with the unified approach, because we have to have it if we keep talking about the 2030, infrastructure needs. This has to be done, now, because as we're building the infrastructure, as well as other companies are, we need to know what the standards are, and the ball really can't move. It needs to stay in the same place. And so that's a great question. I think the answer is going to be, let's see, especially after the big event, some of the big conferences we're going to be seeing in Europe coming up in the fall this year. I think a lot's going to come out of that, because it's going to be the first time where a lot of us have been able to meet face to face instead of these Zoom meetings. And those face to face meetings is where all this actually happens. So it's going to be an exciting year just for standards.
Absolutely. Thanks, Cody. And I can assure everyone watching that HTView has a full event calendar plan for next year where we can do exactly that, exactly what Cody's just said.
Absolutely. And Tina, I'm going to come to you for a question that's come in from Justina, and they ask, does this change of, we've touched on it already, I know, but does this change of PEM membrane thickness impact the purity of hydrogen?
We are targeting, of course, to deliver fuel cell grade or better hydrogen purity on the outlet. But of course, we will have slightly different impurities in our system. But this, we target this, or able to adapt our system design, obviously, to have suitable drying and PSAs to ensure that we have the correct outlet quality, of course. So obviously some changes to what we do inside our containerized solution, but no large changes compared to other PEM systems.
Sure, thank you, Tina. Hopefully that's cleared it up for Justina. And we are running out of time, but one last question for all of you on the panel. What's the main takeaway from this webinar? Looking at the power pillar going forward, what have we learned? Tina, we'll come back to you to start.
Yeah, I mean, I think it's been mentioned here several times, but both Cody and Jako as well, that we need to think of the energy transition as a system, or look at the system as a whole, not only focus on small parts or modules. We need to move fast, and for sure getting more renewables in will help a lot, but hydrogen is then, of course, the great carrier connecting all this together. So we have work to do ahead, but with all the great initiatives out there, I do think we're paving a good direction, and policy is also following up with new efforts. So I think 2022 has been the greatest year this far, and I can only wait to see what's happening else in 2023.
Me too. And Jako, we'll come to you next.
Yeah, two words come into my mind. It's cooperation and communication. So if you look at cooperation, Cody just talked about standards. Here in the Netherlands, I am the chairman of the standardization committee for hydrogen and fuel cells. And it's exciting to see that there's so much cooperation globally on these topics. I mean, we have one hydrogen fueling nozzle for vehicles all over the world, where we still have different plugs for battery electric vehicles, for instance. Those things were standardized about 15 years ago. So that's a good example, I think, of early stage, coordination. And you will need those kind of coordination on various topics globally, which I think everyone sees the urgency, and also is open for this kind of coordination and cooperation, which is wonderful. And as Cody said, 2030, that's tomorrow. You need these actions today. And the other thing is, and that's we have the scientists here and the engineers here in the session. We need we just need to make sure we communicate outside our world, to our outer stakeholders about what we are doing and why this is necessary, and the role of hydrogen in the energy system. Next to all the other, elements of the energy transition, so that we try to avoid that people are wasting each other's time by the useless fights between apples and pears.
Thanks for that, Jako. And finally, Cody, we'll come to you for the final words of this webinar.
Absolutely. So this webinar today, and what I've been seeing just in the last 3 months, is indicative of what needed to be happening, right? So we're now quit talking about cool applications. We're going to quit talking about everything has to do with fuel cells. We actually are now looking at how do you make this a reality. It's not sexy. It's not, something that looks great on the back of a bumper sticker, but the infrastructure is the key, right? Without the infrastructure that we're all discussing today, this doesn't happen. And now with this renewed interest into infrastructure, it opens up the world for not only the media and the public to see hydrogen in a new light. It actually opens up investment opportunities. And so you're going to see a lot of people that have pent up demand for clean energy tech. And I like to use clean energy tech. I think we're going to be getting away from the color spectrum. I've been saying that for quite a while, but you're starting to see more and more people talking about the CI score, the carbon intensity score, and you're going to start seeing that. So we're going to be pretty much molecule agnostic, but every molecule is going to have a CI score associated with it. But that's all those debates are going to be put aside as we talk about rolling this out to the masses. And like I said, this webinar is one of the first I've been participating in, but only in the last 3 months have you started seeing this renewed focus. So I cannot tell you how much I appreciate having the discussion today, a great panelist here for us to get around the table and discuss. And I do foresee a lot of discussions on this topic in the next 9 months to 2 years.
Absolutely, thank you, Cody, and we look forward to bring those discussions as well. But sadly, that is all we have time for today. Our thanks to today's panel. You've been watching Tina Anderson of HiStar, Cody Bateman of Gen H2, and Jako Rajek of eKinetics. And of course, as always, our thanks to you for watching and participating. You can join us here again on August 5th at H2V Webinars, where we'll be discussing the technology pillar and the all-important technologies that will make it happen and lead us to the hydrogen revolution. But before then, something we're very excited about, Rob, is the H2V Hydrogen Summit in San Francisco.
Absolutely, Tom. On July 14th and 15th, H2V will be at the Grand Hyatt in San Francisco, holding our very first in-person event, and it's been a long time coming. We'll be building bridges, hydrogen hubs, and investment. That's our theme, in partnership with the California Fuel Cell Partnership itself, and sponsored by one of today's speakers, in fact, Gen H2. For more details on that or to book your ticket, visit h2-viewevents.com. In fact, let's go one step better than that. For all of you around the world watching here right now, look out for a special message from us straight to your inbox with an exclusive discount for you to attend the event. That's just for you, so don't miss out.
Seems too good to be true, doesn't it? But in the meantime, you can stay up to date with all the latest hydrogen news at h2view.com. But until next time, it's a goodbye from me.
And a goodbye from me.